Welcome to this video on permutation and combination. What are permutation and combination? Basically, permutation and combination are all about the number of ways you can arrange things. In a permutation, the orders matters. What does it mean? It means ABC is a different permutation from CBA. So the order is important. ABC and CBA are different permutation. So how to compute the permutation? The number of permutations of n distinct object is n factorial, where n factorial equal to n times n minus 1 times n minus 2 all the way to 1. For example, if you have 5 factorial, you start with 5. 5 minus 1 will be 4. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. This equal to 120. You can also press your calculator for 5 factorial. You will get the answer 120 directly. Now look at this example. How many permutations are there of the number 5, 8, and 9? The way to do this is to think, how many choices do I have for the first number? And then how many choices do I have for the second number? And then how many choices do I have for the last number? Look here for the first number, we can put either 5, 8, or 9. Therefore, we have 3 choices. Let's say the number chosen is 5. Now for the second number, I only left 8 and 9. Therefore, I have 2 choices. Now I only left one number here, which is 9. So I only have 1 choice for the last number. So the total permutation will be 3 times 2 times 1. This equal to 6. If you want to apply the formula directly, remember the number of permutation of n distinct object is n factorial. So now I have 3 distinct objects. To find the number of permutation, I'm using 3 factorial. This will give you an answer directly, which is 6. We continue on permutation. The number of permutation of R objects selected from n distinct objects is given by NPR. NPR equal to n factorial divided by n minus r factorial. You don't need to worry about this formula. This formula is given in the formula list. And furthermore, you can just press your calculator for your answer. So if you press 6P2 from your calculator, you should have 30 as your answer. If you press 12P4, the answer should be 11,880. Let's look at this example. How many permutation of 4 letters can you make from these words uniform if you don't use any letter twice? So now you're finding the permutation of 4 letters. Your R equal to 4. From this word uniform, uniform had 2, 4, 6, 7 letters. Your N equal to 7. So how to solve these problems? Now you have 4 letters. 1, 2, 3, 4. For the first letter here, you have 7 choices. Then for the second letter, you already choose 1 letter here. You left 6 choices. For the third letter, 2 letters has been chosen. You left 5 letters. And the last one, you left 4 letters. So your number of permutation of 4 letters from this word uniform will be 7 times 6 times 5 times 4, which is equal to 840. So of course, you can actually use the formula directly. You are finding a 7 permutation 4. That is, you want to find the number of permutation for 4 objects selected from 7 objects. Just press your calculator, your answer should be 840 also. Now I'm going to discuss combination. When the order doesn't matter, it's a combination. In a combination, the order of the object doesn't matter. So A, B, C is the same combination as CB8. So what's the formula for combination? The number of combination of R object selected from n distinct objects is given by NCR. That is n combination R. This equal to n factorial divided by R factorial multiplied with n minus R factorial. Again, you shouldn't worry about this formula. It's given in your formula list. Furthermore, you can just use your calculator to find the answer. Like 7 combination 3, your answer should be 35. 8 combination 4, the answer should be 70. Now look at this example here. How many ways are there to choose a team of 11 players from 16 students? How to solve this is very easy. You can just use the formula directly. So you are fighting for 16C11. That is to choose 11 players from 16 students. Just press your calculator. Your answer should be 4,368. So now we start with the first question on permutation and combination. Diagram below show 5 digits. So you have 5 digits, 3, 4, 5, 6, 7, and 3 letters, A, B, C here. A code is to be formed using those digits and letters. The code must consist of 3 digits followed by 2 letters. How many codes can be formed if no letter or digit is repeated in each code? First, we will determine whether this question is a permutation or combination questions. So you can see here, this question is obviously a permutation question because for a code, the arrangement is important. That is, if you have a code 345, this is different from 543. So look at this code here. We have to have 3 digits followed by 2 letters. Now we choose the 3 digits first. We have total 5 digits. So we have 5 choices for the first digits. After we chose 1 digit here, we left 4 choices. Then we left 3 choices. Now we have to choose 2 letters. Total we have 3 letters A, B, C. At first we had 3 choices. After choosing 1 letter, we left 2 choices. Or you can use the formulas to choose the digits, that is 5 permutation 3 multiply with the formula to choose the letters, that is 3 permutation 2. If you press a calculator, 5 times 4 times 3 times 3 times 2, this will equal to 360. And 5p3 times 3p2 will also give you an answer 360. A committee consists of 5 representatives are chosen from 4 Chinese, 2 Indians, and 6 Malays. Calculate the number of different ways the committee can be formed if there are no restriction. This is a combination question because the arrangement or the order doesn't matter. So for part A, you have to find the number of different ways the committee can be formed if there are no restrictions. So you have 4 Chinese, 2 Indians, and 6 Malay. Total, you have 12 people. If there are no restriction, you can just choose 5 representatives from 12 people here. So this is 12 combinations 5. Just press your calculator. Your answer should be equal to 792. Now we proceed to part B, where to calculate the number of different ways a committee can be formed if it consists exactly 2 Malays members. So remember, you have to choose a total of 5 representatives. Now you want to have exactly 2 Malays. Therefore, you need to choose another 3 representatives from either Chinese or Indian. First, you have to choose 2 Malays from 6 Malays. So this is 6 combination 2 multiply with. So remember, you have to multiply, not plus, because the total representatives is 5. So you have to choose now 3 members from Chinese or Indians. You have 4 Chinese and 2 Indians, so total you have 6 people. This is 6 combination 3. You choose 3 members from either Chinese or Indian. Just press your calculator, your answer should be 300. Now we move to part C. We have to calculate the number of different ways the committee can be formed if it consists only 1 Indian and exactly 3 Malays. Again, you have to remember you have to choose 5 representative. So you have 1 Indian's representative, 3 Malays representative. You still need 1 representative here, which you have to choose from the Chinese. So you have 1 Chinese. So this equal to, first you choose an Indian, you have 2 Indians. You choose 1, multiply with, now you choose the Malays, you have 6 Malays. You have to choose 3, multiply with, now you need to choose 1 Chinese. So 4, C1. This is equal to 160. Diagram below shows 6 cards of different letters, so as C, A, N, T, I, and K. Find the number of possible arrangement in a row of all cards. So this is a permutation question because the orders matters. So now we want to find the number of possible arrangement of all the cards. So you have 6 cards here. This equal to 6 factorial, which is equal to 720. So for part B now, we have to find the number of this arrangement in which the letter I and A are side by side. So how to find this arrangement? So now your I and A are side by side. You can put your I and A together. You still have C, N, T, and K. So listen carefully. Now you have 1, 2, 3, 4, 5. So if I arrange these 5 letters here, where I and A consider 1 letters, I and A's are always side by side. To arrange these 5 letters, you have 5 factorial. After we arrange these 5 letters, that's 5 factorial, we have to multiply with the arrangement of I and A. This is because for every permutation, you can actually arrange your IA become AI. Therefore, you need to times with 2 factorial. That is the permutation of these 2 objects, I and A. So press your calculator, your answer should be 240. A school prefect committee of 7 is to be chosen for a group of 8 boys and 5 girls. We have 8 boys and 5 girls, so total you have 13 students. So for part A, you have to find the number of ways can be done if there is no restrictions. So look at this question. This is a combination question because the arrangement is not important. So now we have to choose 7 prefects committees from 13 students. So this is 13 combination 7. Press your calculator. Your answer should be 1716. For part B, we have to find how many ways can be done if there are 4 boys in the communities. So now you need 4 boys in the communities. Remember, you have to choose a committees of 7. So you choose another 3 girls. So the total you have 7 people in the communities. So this equal to total 8 boys. So you have 8 combination of 4. That is 8 boys, you choose 4. Multiply with, you have 5 girls, you need to choose 3. This is 5 combination 3. Just press your calculator, your answer should be 700. Now for part C, we have to find how many ways can this be done if not more than 2 girls in the communities. So how to choose this community? We can choose 2 girls, which is not more than 2, and 5 boys in a community of 7, or you can choose 1 girl and 6 boys. Or you can choose 0 girl and 7 boys. This equal to choose 2 girls, this is 5C2 multiply with, now you need to choose 5 boys out of 8 boys, so this is 8C5 plus, now you have to choose 1 girl and 6 boys. 1 girl is 5C1. To choose 6 boys is 8C6 plus 0 girl means is 5 girl, C0 multiply with 8 boys, you choose 7. Just press your calculator, your answer should be 708. A committee of 7 is to be chosen from a group of 6 men and 5 women. So now we have 6 men and 5 women. So for part A, you have to find in how many ways can this be done if the number of women must be greater than the number of men. So you need to choose a committee of 7 and the women must be greater than the men. So you can choose 5 women with 2 men. So this total will be 7, or you can choose 4 women with 3 men. So this is the only choice you have, because if you choose 3 women, then you have to choose 4 men. The total must be 7. Now the women will be less than the men. So now you only have 2 choices here. So this equal to, you have 5 women, so 5, choose 5, multiply with, you have 6 men, you choose 2, plus 5 women, you choose 4, multiply with 6 men, you choose 3. Just press your calculator, your answer should be 175. Now for part B, you have to find the number of ways can this be done if the number of men must be greater than the women. So now we have 6 men, we have to choose a committee of 7. So we can have 6 men, 1 woman, or 5 men, then we have 2 women, total is 7, or we have 4 men and 3 women. So this is the 3 choices we have, because the number of men must be greater than the women. So this equal to, 6 men, you choose 6, multiply with 5 women, you choose 1, plus 6 men, you choose 5, multiply with 5 women, you choose 2, plus 6 men, you choose 4, multiply with 5 women, you choose 3. Just press your calculator, your answer should be 215. Diagram below shows 8 letters from equations. A 5-letter code is to be formed using 5 of these cards. So part A, we have to find the number of different 5-letter codes that can be formed. So this is a permutation questions, because the orders or the arrangement is important. Now we have to arrange 5 letters from 8 letters. So this is 8 permutation 5. Just press your calculator, your answer should be 6720. Now for part B, we have to find the number of different 5-letter codes which end with a consonant. So what is a consonant? So A, E, I, O, U is a vowel. The consonants here should be Q, T, and N. So now you have the 5-letter codes. You must end with either Q, T, or N. So you have 3 choices here. So after chosen 1 letters here, you will left 7 letters. So here should be 7 permutation 4. You have to choose 4 letter from the 7 letter left. So the answer for this will be 7P4 multiplied with 3. So this equal to 2520. Diagram below shows 7 cards. So you have 2, 3, 4, 5, 6, 7, 8. Total has 7 cards here. A 4-digit number is to be formed by using 4 of these cards. So for part A, how many different numbers can be formed? So this is a permutation question because the orders and arrangements is important. So to form a 4-digit number, from the 7 cards here, first you have 7 choices. After you choose 1, you have 6 choices. After you choose 1, you have 5 choices. Then you have 4 choices. This actually equal to 7 permutation 4. Just press your calculator. Your answer is 840. For part B now, we have to find how many different even number can be formed. So you have 4 digits now. If you want to form an even number, the number here should be either 2, 4, 6, or 8. Therefore, you have 4 choices here. After you chose one of this number here, you left 6 cards because before that you have 7 cards, now you left 6 cards. So from the 6 cards, you need to choose another 3 numbers. So this is 6 permutation 3. So the answer equal to 480. How many numbers greater than 5,000 can be formed using digits 3, 4, 5, 6, 7 without repetition of digits? So listen carefully here. You have total 1, 2, 3, 4, 5 number. So you can form a 5 digits number. From this 5 number here, this equal to 5 times 4 times 3 times 4 times 1, or you can just put 5 factorial, which is equal to 120. So the 5-digit number definitely will be more than 5,000. You also can form a 4 digits number. Now to form the 4 digits number, to get a number greater than 5,000, you have to choose either 5, 6 or 7. So you have 3 choices here. After you choose one of this number, you left 4 numbers. So now after choosing one of this number, again you left 3, then you left 2. So if you press the calculator, so this equal to 72. So now you have to plus these two together, that is 72 plus 120. So this 120 here is the 5 digits, which is definitely more than 5,000. 72 here is the 4 digits number that is more than 5,000. So your answer should be 192. 3 girls and 4 boys are to sit on 7 chairs in a row. So now I have 3 girls, 4 boys, and I have 7 chairs. 1, 2, 3, 4, 5, 6, 7. So for part A, I have to find the number of different possible arrangements if there is no restriction. So this is a permutation questions because the number arrangements is important. So now to put these 7 people on these 7 chairs, I have 7 factorial. That is 7 multiplied with 6, 5, 4, 3, 2, and 1. This equal to 5,040. So for part B now, we have to calculate the number of different possible arrangement if 3 girls are to sit together. So how to do it here? We can put all the 3 girls as one object. I still have 4 boys here. Let's say boy 1, boy 2, boy 3, and boy 4. Now I have to arrange how many objects? 1, 2, 3, 4, 5. So this equal to 5 factorial. Now I have to multiply with the permutation of the 3 girls, which is 3 factorial. The answer equal to 720. So now for part C, we have to calculate the number of different possible arrangements if 2 of the boys are to sit at the 2 ends. So now you have 1, 2, 3, 4, 5, 6, and 7. Let's say 2 boys, that is boy 1 and boy 2, are to be seated at 2 ends. So now you left 5 chairs in the middle, which you are going to arrange 3 girls and 2 boys. So this equal to 5 factorials. Remember, you have to multiply with 2 factorial because you still can arrange the boy 1 and boy 2. You can switch where the boy 1 will be seated here and the boy 2 is seated here. So 5 factorial times 2 factorial, the answer is 240.